This is part 2 of section 3.1, Measures of Central Tendency. Weighted means are used when not all of the values are equally represented. To find the weighted mean, you need to take the weights and multiply them by the data values. Add them all together, and then divide by all of the sum of the weights. Grade point average is a great example of weighted means. Basically, each grade you get is weighted depending on how many credits you have and what grade you get in each credit. In this particular example, we have an English composition class that is 3 credits, and the grade received was an A. A's are 4 points. Looking through the next one, you have a psychology class, 3 credits, receiving a C. That's worth 2 points. Biology class, 4 credit class, getting a B, which is 3 points. And physical education class, 2 credits, but getting a D in that one. To find the grade point average for this, we need to multiply the credits times the weight of that credit. As you can see, here is the formula that you would use. I'm going to show you using the graphing calculator how that can all be done in one step. The first thing that I do is I put in my top value of that fraction. I took my parenthesis so that the calculator knows I want the calculator to add those parts up first. So I use parentheses, typing in that first credit times the weighted score, then the second credit times the weighted score, until I got all of my credits. Making sure that I put a parenthesis at the end. Then I need to divide by how many total credits I was taking. So you can do another set of parentheses and go 3 plus 3 plus 4 plus 2. And using the ending parentheses, then hit enter. As you can see, it gives you your grade point average. Typically, we'd round it to the nearest tenth. So our grade point average is 2.7. Properties of the mean. Found by using all the values of the data. It varies less than the median or the mode. It's used in computing other statistics such as the variance. It is unique. It's usually not one of the data values. Cannot be used with open-ended classes. And it is extremely affected by high or low values, which are called outliers. If this is the case, then it is not appropriate to use the mean because it will throw off your data. Properties of the median. It gives you the midpoint. It's used when it is necessary to find out whether the data values fall into the upper half or lower half of the distribution. Can be used for an open-ended distribution, and it is affected less than the mean by those extreme high or extreme low values. Properties of the mode is used when the most typical case is desired. It's the easiest average to compute, can be used with nominal data, and it's not always unique or may not even exist. you can have more than one mode or no mode at all. The mid-range is easy to compute. This gives you the midpoint, and it is affected by extreme high or low values in the data set. Here are some common distributions and where the mean and the median and the mode lie within those distributions. The first example is positively skewed. Notice that the majority of the values fall to the left of the mean in this area here and tail to the right. The mean is to the right of the median and the mode is to the left of the median. Then we have what we call symmetric. The data values are evenly distributed on both sides of the mean. Notice how it's going in an upward direction and then going back down. When it is unimodal, as in this case, there's only one mode. The mean and the median and the mode are all the same, and they're at the center of the distribution. Then the last example, negatively skewed. The majority of the data fall to the right of the mean in this area. And they have a cluster to the upper end of the distribution and they tail off to the left. The mean is to the left of the median. The mode is to the right of the median. This concludes section 3.1. Please now go to Connect Math and work through your examples in that website. Thank you.